Let's take a look at this example. Again, we're supposed to find Z11 first. We have two loops, one more time. This is my loop 1, and this is my loop 2. Z11 is equal the sum of all impedances in loop 1. I'm going to have R1 plus R2 plus R3, which is equal 7.2 kilo plus 9.2 kilo plus 4.2 kilo. This is equal 20.6 kilo ohms. This is my impedance Z11. Next, impedance Z12 is equal to impedance Z21. This is impedance between these two loops. Okay? The impedance between these two loops is equal to R2. And this is equal 9.2 kilo. Next, I have to find Z22. Z22 is the sum of all impedances in loop 2. I have R2 plus R4 plus R5 and plus R6. This is equal 9.2 kilo plus 10 kilo plus 6 kilo plus 9.2 kilo. Z22 is equal 34.4 kilo ohms. Next, we're supposed to find the sum of the voltages in loop 1 and loop 2. Please keep in mind that the short bar of the power supply represents the negative terminal and the long one represents the positive terminal. So I'm going to have negative, positive, and positive and negative. We use the conventional current flow, means we assume that the current flows from positive terminal to negative. That's why I'm going to say that this voltage source is going to push the current in this direction. This one is going to push down, and this one is going to push current up. Please notice that these two currents are going to oppose each other. That's why I'm going to write the sum of the voltages in loop 1 is equal, because these two currents are opposing each other, I have to write the negative sign first, and I'm going to have negative V1. Now, let's take a look at the second voltage source. These two currents are going the same direction, right? That's why I'm going to write plus V2. And I'm finished with the first loop. Let's take a look at the second one. Sum of the voltages in loop 2 is equal. Look at the direction of the loop current. This current is going to oppose my V2 current, the current which is pushed by the voltage source V2. They are going to oppose each other. That's why I'm going to write this is negative V2, and this voltage source also is going to push the current in a direction which is going to be opposite to the direction of the loop current. That's why I'm going to write that this is negative V3. This is very important. Many students got confused about it, and many times they got wrong answers on the test. Please keep in mind, you have to look always at the loop current. If the loop current is going to have the same direction like the voltage source current, means this voltage source is going to have positive sign. in the equation. If the currents are going to oppose each other, see? They're opposing. This one goes down, this one will go up. They're opposing. That's why we have negative signs. Many students are confused about it. So this is equal. Negative V1 is negative 24 volts plus V2, which is equal 32 volts, equals 8 volts. And I have negative V2, negative 32 volts, minus V3, which is equal 5 volts, is equal negative 37 volts. Next, we can write the mesh equations. To write mesh equations, I'm going to use the general formula. I have I1 times Z11. Z11 is equal 20.6 kilo minus I2. Z12 is equal 9.2 kilo equals the sum of the voltages in loop 1. This is equal 8 volts. This is my first mesh equation. Next, I have negative I1 and I have Z21, which is equal 9.2 kilo plus I2, and Z22 is equal 34.4 kilo, and this is equal negative 37 volts. These are my mesh equations. Next, I can start to calculate I1. We're going to use determinants again. First, we have to calculate the delta. In order to calculate delta, you're supposed to use the integers which are next to I1 and I2. So I have Z11 minus Z21, and I have negative Z12 and Z22. I'm going to plug in the numbers. So remember, Z11 is my 20.6 K, negative Z12 is negative 9.2 K, and negative Z21 is negative 9.2 K, and Z22 is 34.4 K. I have 20.6 K minus 9.2 K, negative 9.2 K, and I have 34.4 K. Let's solve this determinant. I have 20.6 K times 34.4 K minus negative 9.2 K times negative 9.2 K. The answer is 624 mega ohm square. This is my delta. Next, we're supposed to find NI1. NI1 is equal, again, determinant, but the first column of your delta determinant you're supposed to replace by the constants. Some of the voltages in loop 1 and some of the voltages in loop 2. The second column is going to stay the same. You simply copy down minus Z12 and Z22. Plug in the numbers. You will have 8 volts and minus 37 volts, and I have negative 9.2 K, and I have 34.4 K. equals. We're supposed to solve this determinant, and I have, this is equal 8 volts times 34.4K minus negative 9.2K times negative 37 volts. This is equal negative 65.2 kilovolt ohm. This is the value of NI1. Next, I'm supposed to find I1. I1 is equal NI1 over delta. NI1 we calculate is negative 65.2 kilovolt ohm. Divide by delta, 624 mega ohm square. Ohm and square cancels out, and I1 is equal negative 104.48 microamps. This is the value of current I1. Please notice that this time we got the negative value of the current. What this negative value is telling me, this negative sign is telling me, this sign is telling me that the real current in the circuit, not the assumed one which we did at the beginning, right? We assumed that I1 will go clockwise, and we assume also that I2 will go clockwise. This negative sign is telling me that the current I1 is not going to go clockwise, it's going to go counterclockwise, it's going to against the direction which I assume. So this negative sign is telling me that. Also, please notice that the current I1 is going to be equivalent to current IR1 and also to current IR3. The same current will go through resistor R1 and R3. And this is going to be called negative 104.48 microamps. Next, we're supposed to find NI2. NI2, I'm going to calculate by using the integers which are next to I1 in the first column, and I'm going to use the constants, the sum of the voltages in loop 1 and sum of the voltages in loop 2 in the second column of my determinant. Next, I'm going to plug in the values of Z11 and Z21 and the sum of the voltages in loop 1 and loop 2, and they are 20.6K minus 9.2K, and I have 8 volts minus 37 volts. Now I'm supposed to solve the determinant. This is equal 20.6 kilo times negative 37 volts minus 8 volts times negative 9.2 kilo ohms. Is equal negative 688.6 kilovolt ohm. This is the value of my NI2. Next, I can find the current I2. I2 is equal NI2 I2 divided by delta. This is equal NI2 negative 688.6 kilovolt ohm over delta, which is equal 624 mega ohm square. Ohm and square cancels out, and if you are going to divide these two values, you are going to get 1.1 milliamp, and of course negative 1.1 milliamps. Please keep in mind that this current is also negative. This negative sign is telling me that in reality the current is not going to go clockwise in this loop. It's going to go counterclockwise. This negative sign is telling me that. Please also notice that I2 is equivalent to the current which will go through resistor R4 and is going to be equal to the current which goes through resistor R5. That's why I'm going to write that I2 is equal IR4 and is equal to IR5. This is equal negative 1.1 milliamp. Let's continue. Next, we're supposed to find voltage across resistor R1. Remember, we said that the voltage we can calculate from Ohm's law. Ohm's law says voltage is equal current times resistance. Voltage across resistor 1 is nothing else just the current which goes through this resistor times the resistance. VR1 is going to be equal IR1 times R1. Remember, we said that I1 is the current which goes through resistor R1. That's why I'm going to use this value. I can call this current also IR1 or IR3 because I1 will go through this resistor R1 and resistor R3. I1 is equal negative 104.48 microamps times R1, which is equal 7.2 kilo. This is equal negative 752.25 millivolts. This is the voltage across my resistor R1. Okay, so if someone is going to ask about the polarity across the resistor, please keep in mind that this is the current which we assume, and because I have negative sign, right, from my calculations, means the real current will go in the counterclockwise, so the polarity across the resistor is going to be positive and negative. Remember, anytime current enters the component, you're supposed to write positive sign. Anytime it leaves, you're supposed to write negative. Because this current is negative, means that the current is going to oppose the loop current which we assume, and this current is going to, the real one, is going to enter the resistor from the right side and is going to leave on the left side, right? So it means that this is going to be positive terminal and this one is going to be negative. Next, we're supposed to find VR5. VR5 is IR5 times R5. But we said that IR5 is equal to I2. Okay, because this current is going to go through resistor R5. I2 is equal negative 1.1 milliamps times R5, which is equal 6 kilo. This gives me negative 6.6 volts. So this is voltage across resistor R5. Again, someone can ask about the polarity of this voltage across this resistor. Please keep in mind that the real current is going to go in the opposite direction to the current which we assume. So the real current is going to go counterclockwise. So the real current is going to enter the resistor from the left side. That's why this is going to be positive sign, and this one is going to be negative. So this is the polarity of the voltage across this resistor. We are going to have positive terminal on the left side and negative on the right side. Next, we're supposed to find power across resistor R2, power at resistor R2. So we have to find the current which goes through this resistor first. R2 is going to be equal I1 minus I2 is going to be equal to the difference of these two currents. Why difference? Because they are going to oppose each other at this component, because this one is going to go down and I2 will go up. They are opposing. Anytime they are opposing, you're supposed to subtract them. I1, we said, is equal negative 104.48 microamps minus I2, which is equal negative 1.1 milliamps. This is equal 995.52 microamps. 995.52 microamps. This is the current at this resistor. Next, we're supposed to find the power at this resistor. P R2 is going to be equal I R2 squared times R2, which is equal 995.52 microamps square times R2, which is equal 9.2 kilo. This is equal 9.11 milliwatts. This is the power at this resistor. Next, we're supposed to find the power at resistor R6. Formula for power says P R6 is equal current at resistor R6 square times resistor R6. Current which will go through this resistor is nothing else, just current I2. Keep in mind, this current will go through resistor R4, R6 and R5. So I'm going to use value of I2 over here. I2 is equal negative 1.1 milliamp square times R6, which is equal 9.2 kilo. This is equal 11.13 milliwatts. So we've found all the answers to our problem.